Hello everyone, myself Sarananda Gowda. My user number is 1VE21CS147. Today I am going to explain random forest. Introduction to random forest. Random forest is an ensemble learning method primarily used for classification and regression. It combines the predictions of multiple decision trees to improve accuracy and control overfitting. The technique was developed by Leo Bremen and Adley Cutler in the early of 2000. Random forest classification consists of instance random forest, tree 1 class X and tree 2 class Y, tree N class X, final class majority voting, final class. How random forest works. Random forest create multiple decision trees by using um, bootstrapped samples of the training data. Each tree is trained independently, and only a subset of features is considered for splitting at each node. The final prediction is made by the aggregating the predictions from all division trees, typically by majority voting for or averaging. Dataset decision tree 1, decision tree 2, decision tree 3, decision tree n. Result 1, result 2, result 3, result n. Majority voting, find result. Key advantages. Random forest is robust against overfitting compared to the single decision tree. It can handle large dataset with higher dimensionality efficiency. The model provides future importance scores, helping to understand the impact of different variables. Here we can see the diagram. Key disadvantages. Random forest models can be more complex and less interpretable than single decision tree. They require more computational resources and memory, especially with large number of trees. Predictions can be slower due to the need of aggregate result from multiple trees. Hyperparameters of random forest. Important hyperparameters includes the number of trees, n estimators, and the maximum depth of each tree. The number of features to consider at each split maximum features can also grade affect model performance. Turning these hyperparameters is a crucial for optimizing the model's accuracy and efficiency. Applications of random forest. Random forest is widely used in the fields such as financial credit scoring and fraud detection. It is also applicable in healthcare for disease prediction and patient stratification. The method has been successfully employed in the environmental science for species classification and prediction. Random forest classification includes instance random forest, tree 1, tree 2, tree n, class X, class Y, and class X. Majority voting, final result. Random forest versus other algorithms. Compared to the logistical regression, random forest can model complex and non-linear relationship better. While supporting vectors mechanism may offer better performance on small datasets, random forest scales well with large datasets. Random forest often outperforms individual and decision trees by reducing variance and improving accuracy. Dataset decision tree 1, decision tree 2, decision tree 3, decision tree n, result 1, result 2, result 3, result n, majority voting, final result. Features and importance in the random forest. Features importance can be assessed using the mean decreases impurity or uh, permutations importance methods. This helps in identify the most influential features in the dataset. Understanding features importance aids in the model interpretation can guide future data collection. Limitation and consideration. Random forest may struggle with high imbalanced datasets where certain classes are underrepresented. The model complexity can lead to difficulties in visualizing and explaining results to non-technical stakeholders. Ensuring that the model generalizes well requires careful validation and testing. Future directions in random forest research. Research is ongoing to improve the efficiency of random forest algorithm for large-scale applications. This is interest in combining random forest with deep learning models for enhanced prediction performance. Further, future studies may focus on refining futures selections techniques to further enhance model interpretable and accuracy. Feel free to modify any part of this outline for special needs. Thank you. I hope you all understand well.